Hi, everybody. We're going to do Algebra 1, IXL, of course, and we're in the section K about single variable inequalities. Now, we just did K3 or K4. I did K4 for you, and I'm going to do K5 right now, which is solving inequalities with multiplication or division. Now, there's one extra little thing that has to be remembered when you're dealing with inequalities instead of equations. And that is when you multiply or divide by a negative on both sides, you're changing the sign, so you have to change the sign. And I'll make sure I include that instruction in there, and we'll get started. And let's see, what's our first one? Okay, so we have b divided by 2 is greater than 2, and we're going to multiply by 2 on both sides. I'm going to go ahead and write out the first few anyway, so you can see them. b, put a tail on it, over 2 is greater than 2. Remember, we always do the opposite to both sides in reverse order in order to solve equations and inequalities. So I'm going to multiply by 2 on both sides. Now, this is a slightly different situation than it is when you're dealing with equations, but we can see that it's going to work. B is greater than 4. And in fact, one way to test it is to choose a number that's greater than 4, for example, 10, and see if it's true that 10 divided by 2 is greater than 2. And we can see that it is. It's just a way of testing your solution to make sure that you're going the right direction. Now, of course, you should be able to graph this. If you did the first two, you will recognize that this is the graph of an inequality. And we want an open circle at 4 because 4 can't be greater than 4. And all the numbers to the right. We sometimes put a parenthesis. Some books will do it this way. And finally, our interval notation, which would be with a parenthesis. We start at 4 and we go to infinity, or at least get as close as we can. So this would be all the ways of writing the solution to this. They're looking for this one, so we're going to put that one in there probably. B is greater than 4. Okay. Now, if we have to multiply or divide by a negative, oh, no such luck. So we just have J divided by 3 is less than 3. Here's a common error. I'm going to do it wrong on purpose just to show it to you. Sometimes it's easy to make an error. If you see this, it is very tempting for a lot of students to do the following, because a lot of times they see a number divided or a variable divided by a number. They want to do the same thing to the other side. There's a whole bunch of problems with this, but basically I'm dividing by 3 on this side over here and not doing anything to this side because my original said this. So be careful, that is incorrect. What we want to do is multiply by 3. And if you like, that's 3 over 1. And we end up with J is less than 9. And again, a good way to test it is to try a number that's less than 9, like 0. And sure enough, 0 is less than 3. 0 divided by 3 is just 0. And it's good to go. So J is less than 9. There we go. Now, the one problem that you're going to run into is when you're dealing with negatives. Still no negatives. H over 4 is greater than or equal to 2. I'm going to multiply by 4 on both sides. Some people have a little trouble with how this should be written, but basically the 4s simplify out. Some people like to write the 4 over 1, it's the same thing. H is greater than or equal to 8 in this case, and you can hopefully draw the graph of that. Here's 0, and here's 4, and here's 8. Notice that I'm counting by 4s so that it's a little bit nicer. And we have a filled in circle because 8 is included, and we want to go in this direction because we want it to be greater than 8. Be careful when your H is on the right, it could have messed us up. Now this is a graph of the solution set. And if I were to do interval notation, I would use the brackets to indicate that the 8 is included and goes to as close as we can to infinity. And some people will include the bracket instead of the filled in circle. So there's all of your possible solutions for this. IXL is asking for H is greater than or equal to 8. We're all done. And in this one, we're going to multiply by 2, and I'm just going to write the answer in. D is less than or equal to 4. And going to multiply by 3 on both sides. H is less than or equal to 9. I think we did that one before. And now we've got it. Okay, so now we've got a little problem, and I really want you to understand. And it's not hard to understand if I show you something. This is called the properties of equality. I'm going to show you those just real quick. Everybody could agree that 5 is equal to 5. And no matter what I do to both sides of this equal sign, it's still going to be true, so long as I do it to both sides equally. For example, I could add 3 to both sides, and it's still true. Everybody can see that. I could multiply by 3, and it's still true. This is called the addition property of equality. This is called the multiplication property of equality. I have a division property of equality. And I get 6 equals 6. That's the division property of equality. And I could even multiply by a negative. Still doesn't matter. Let's say -6. No, -5. I'm going to multiply by -5 on both sides, and I get -30 equals -30. And this, again, is the multiplication property of equality. So there's all kinds of properties of equality, and they all work. You can do the square root of both sides. You can do the cube root of both sides. You can take the tangent, the sine, the cosine of both sides. Basically, anything you want to do, you can do to both sides. And it'll stay balanced. It's kind of like a balance scale. Now, when you're dealing with inequalities, I just want to show you that adding and subtracting still have the same inequality. For example, if you've got -2 is much less than 5. In fact, they have a difference of 7. You can see that 5 is 7 bigger than -2. There's 2 ways to read this inequality. -2 is less than 5. You can also read it the other way. 5 is, if I'm reading it this direction, 5 is greater than -2. Now, I can add or subtract anything I want from both sides. If I add, say, 7 to both sides, I get 5 on this side is less than 12. And I want you to notice that they still have the same amount of difference between them. I can subtract anything I want, and I can also multiply. Now, the multiplication is going to change how far apart they are, but it's still, this side is going to be smaller than the other side. So I can multiply by 2, for example. And I get 10 is less than 24. Hopefully all that is clear, but here is where we run into a problem. Suppose I have 10 is less than 24, and I multiply, let me do one more thing. Let me subtract 12 from both sides. And what I end up with is -2 is less than 12. Most people can see that this is true. That's because of the subtraction property of inequality. Now I'm going to do multiply by -1. I'm going to multiply this side by -1, and I'm going to multiply this side by -1. And what you're going to get is +2 is less than -12, and that's wrong. You see, what I've done is I've changed the sign of both sides. And what that does is it changes the sense of the inequality. Basically, I've jumped the number line from the right side of 0 over to the left side and vice versa. Basically, what you have to remember, and it's very simple knowledge, is that if I multiply by -1 on both sides, it's going to change this sign because I've changed the sense of the inequality. And I get R is greater than +9. And I'm going to go ahead and give you some more examples of that, and we'll actually test to see if it works. But of course, r is greater than 9. We change the sense of the inequality. I know that was a lot of information, probably too much information, but we'll just practice it from now on. So I'm going to multiply by 2, and I'm going to get 8 is greater than t. That's how you read this. Now, I could also read it the other direction, which says t is less than 8. And I can rewrite it this way. It doesn't matter which one you put. You can test it by putting in 0, for example, and we can see that 0 is less than 4, or 4 is greater than 0. I'm going to put in the second one. T is greater than 8, and keep going. I'm sure you guys want to get done. Oh, I wrote it on the side and then put it in the wrong way. Sorry about that, guys. It should have been t is less than 8, duh. Okay, so here we go. I'm going to divide by 10 on both sides, and I'm going to have n is less than or equal to 2. And I'm going to write it the right way this time. N is less than or equal to 2. And we're going to get moving here. If I get another negative, I'm going to go ahead and test it. Oh, here we go. So g divided by -5 is greater than 2. And what I'm going to do this time is I'm just going to follow the rule, which says I'm going to multiply by -5 on both sides. Hopefully everybody's clear on why I'm doing that. And it's going to cancel out the -5s, give me 1s. I'm going to have g, but I have to change the sign. And it means g is less than -10. Now what I'm going to do is I'm going to choose a number that is less than -10. Now, hopefully you guys remember that on the number line, to get less, you have to go to the left. So I'm going to say -15 is less than -10. And I want to test it in my equation, or in my inequality rather. -15 over -5 is supposed to be greater than 2. Let's see if that's true. A negative divided by a negative is a +3. And this is true. And I've checked my solution. Notice I changed the sign because when I multiplied both sides by -5, I changed the sign. So be careful. Now I'm going to put it in right. G is less than -10. There we go. And now I'm going to multiply by 2 and get P is greater than 10. And now I'm going to divide by 2 and get B is less than 4. And now I'm going to divide by -3, and I've got all kinds of problems here. First of all, I have -18 is greater than or equal to -3a. If you were going to graph this, you would have all kinds of problems. But here's what I'm going to do. I'm going to start by dividing by -3 on both sides of my inequality. Now that's going to change the sign, which is going to change the sign to less than or equal to. The a stays where it is. And this is going to be +6. Now I'm almost done, but the problem is that if I were to graph this, it would be very difficult to graph. People have a little bit of trouble reading these backwards. So a good idea is to maybe rewrite it as a is greater than or equal to 6. That way, if you were to graph it, it would look like this. I'm going to count by 3s. And this is a, so it's a good idea to label your graph. And we're going to have a filled in circle at 6. And this arrow tells us we're going to go a is greater than or equal to 6. Remember, I could use a bracket, same thing. And I could write my interval notation as 6 going up to and getting closer and closer to infinity. Now, all of these things are solutions, supposedly, to this inequality. Now, a good idea is to actually pick an answer and see if it's true. So I can pick any number I see here, and the number I'm going to pick is 9. Now, I could pick 6 because it says it could be equal, but I'm going to go ahead and pick 9 because I want to make sure that my arrow is going in the right direction. So I'm going to choose 9. So let's see. -18 is greater than or equal to -3 times a. So I'm going to substitute for A, and I'm going to choose the value 9 to see if it's true. And some people are going to get freaked out by this, but remember, negative 18 is greater than negative 27, isn't it? It's better to owe 18 than it is to owe 27. So it does check out. A is greater than or equal to 6. All right, for the rest, I promise I'm just going to do them. I'm going to multiply by negative 1 and change the sign. So P is going to be greater than or equal to 12. And I'm going to divide by negative 1, and I'm going to get 2. Remember that we have to change the sign, and n is on the other side. So n is greater than 2. And you could pick some numbers and test it and everything. Remember, you got to change the sign when you multiply or divide by a negative on both sides. We get W is greater than or equal to 12. And we're almost done. It looks like, oh, got a few more to go. Divide by negative 3. We get 18. We have to change the sign. And we are talking about dividing by negative 3 on both sides. I'm going to go ahead and put in the work here. That gives me A is greater than or equal to, A is less than or equal to negative 6. It is really easy to mess this up. A is less than or equal to negative 6. I multiplied or divided by a negative on both sides, so I have to change the sign. I can't see it anymore, but I think it's this way. No, it's this way. There we go. What? Did I get the wrong direction? I got to read my... Okay. That's okay. I'm going to be a little more careful. Sorry, guys. There we go. Multiply by negative 1 on both sides, and we get less than negative 2. F is less than negative 2. The reason it gets confusing is because you're changing the sign, and then I turned it around, so it ended up being both things. All right, let's see, what's next? Multiply by 2 on both sides, and we get Y is greater than or equal to 6. Z is less than 11, because we're multiplying by a negative 1 and changing the sign. Notice that multiplying by a negative 1 is the same as dividing by negative 1. Either one has the same effect. We end up just changing the sign. And notice I had to change the sign. I'm hoping that they give me one where I can show you a common error on this. A is greater than 40, other than the one I made. Alrighty then, we're going to multiply by 18 on both sides. A lot of people are going to be very tempted to divide or something, or do something crazy like that. You're going to multiply by 18, and it's a positive, so we get 2 is less than or equal to, it looks like 54. Huh? We're multiplying by 18, yep. And let's see, what's next? We're going to divide by negative 2 on both sides, and we're going to get C is greater than negative 5. Because we divided by a negative 2 on both sides, we have to change the sign. We're going to divide by 13. We're going to get Q is less than 4. A lot of people are wondering how I divided 52 by 13. Remember, there's 52 cards in a deck, 13 in each suit. So 4 times 13 is 52, my favorite number. Just so you know, think about cards in a deck and you'll remember it, hopefully. Multiply by 6 on both sides, we get A is greater than 18. Yep. I'm going to double check when I'm doing these. All right, we're almost done, guys. And we're going to multiply by negative 217, and we're going to get the N is less than 217. Got to change that sign. And this time, the K is on the wrong side, but I'm just going to leave it there. We're going to divide by 4 on both sides, and we're going to get 63. So we're dividing by 4. We get 63 is less than or equal to K. And I'm just going to divide by 4, and that is correct. Let's see here. We're going to multiply by -3, which is going to change our sign. And we're going to have H is greater than, looks like 48, huh? And it's a positive because I multiplied a -3 on both sides. And we're going to divide by 3. We're going to have H is greater than or equal to 6. All right, I got to this one. Okay, this is a common mistake, and a lot of students make a mistake on this one, and I'm going to show you why. F over 3 is greater than or equal to -2. And they know they have to multiply by 3 on both sides. And they say, I'm going to multiply by 3 on both sides. And I want you to guess at what the mistake is. See if you can guess what mistake people make on this. Think about it. F is less than or equal to -6. And here's the problem. A lot of students are going to make the mistake of changing the sign. And the reasoning is that, does everybody see I multiplied by a negative? But here's the thing. I multiplied by +3 on both sides, didn't I? Because I multiplied by a +3 on both sides, the signs didn't change. You see, this -2 is still a negative. And this positive F over 3 is still a positive. The signs didn't change because I multiplied by a +3 on both sides. I don't change the sign unless I multiply both sides by a negative. So be careful. It is a really easy mistake to make. And it seems like I'm lying when I say that you have to change the sign when you multiply by a negative. But remember, that only happens when you multiply both sides by a negative, okay? And we're almost done. We're going to divide by 5.22, which is going to be R is less than or equal to 3. And yep. And we're almost there. We're going to multiply by 1.21. So F is going to be less than, looks like 8.26. I'm going to go ahead and multiply it on the side just to show you. I'm multiplying. That's going to be 6 and 2 and 1. Look what I did. That's why you check your answer. Less than 7.26. I carried twice is what happened. Always a good idea to check your answer. And we're going to multiply by we're going to multiply by 3.55 on both sides. Here's that mistake again. We don't change the sign. H is greater than or equal to -3.55. We do not multiply by a negative on both sides. We multiply by +3.55 on both sides. So the sign stays. And maybe 1 or 2 more. We're going to multiply by 3.87. I'm going to go ahead. There's a lot of carries going on there, so I'm going to go ahead and multiply it on the side. Some people are going to grab their calculator and turn off their brain. It's always good to do your multiplication tables. It's surprising how easy it is to make a mistake. 6, carry the 2, and that's 11. And we move it 2 decimal places. A few people are going to say, well, why should I practice when I've got a calculator? Well, one of the things that you want to keep in mind is that a lot of you are thinking about going to college, and you're going to take a thing called the AccuPlacer. And unfortunately, the first thing the AccuPlacer asks you is arithmetic questions. And they want to see, do you know your basic arithmetic? And it'll ask things like division problems, multiplication problems. And if you can't get past that, you're going to end up taking remedial math in college for no credit. I happen to know all this because I was a college professor for 12 years and I taught remedial math. And remedial algebra, which is algebra 1 and algebra 2 for college that you don't get any credit for. So you don't want to have that happen to you. 11.61. 11.61. Hopefully that's right. Oh, helps if you put in the inequality, doesn't it? All right. We're going to multiply by 4 on both sides. So z is greater than 288. Yeah, you get distracted and you forget what you're doing. This looks like 17, huh? 51 divided by 3 is 17. And we're going to divide by 1.5 on both sides. We're going to get 2 is greater than z. We're just dividing by 1.5. And we're going to multiply by 1.08. Let's see if I can multiply today. 6.5. This is one of those cases where if I was a student, I know for sure I would grab my calculator. But anyway, that is 40. And we've got a 5 at the end. We have a 0 and another 0 and a 6. And did I forget something? Oh, no, 6 times 8 is 48. Carry the 4. This is easy to make a mistake. That's going to be the 4 and then the 6. And we're going to add this together. Wow, that's really funky looking. 0, 4, 3, 1, 5, 6. And I've got 3 decimal places. Wow, that is really ugly. That is definitely not right. So I made an error somewhere, probably in my carries or something. I'm going to do it one more time. Let's go with, 1.08 times 6.5. Now, a lot of teachers will tell you, oh, I pretend to make mistakes because I want to see if you'll notice. So I'm pretending to make mistakes. Yeah, that's it. 0, carry the 4. That gives me my 5. I have 1, 2 zeros, and then I have a 65. And then I have a 0, a 4, a 0, and a 1, and a 7. And I have 3 decimal places. Now, this is where estimation comes in handy. When I estimated 6 times 1, or a little more than 6 times 1, I definitely did not get 65. I got something a little bigger than 6.5, which is 7.04. So that's what I'm going to put in. 7. Almost did it again. A is less than or equal to 7.04. There we go. What did I do? Oh, 2. Did I do that wrong? I did. All right. Well, there we have it. Hopefully you will take my advice and practice your arithmetic a little. Obviously, I need some. Greater than 18. There. Oh man, how embarrassing. Okay. That's why a lot of YouTubers actually write and make sure that they're actually correct when they do these. 174. I almost put 172. Geez. I'm going to multiply by 2 on both sides and get b is less than negative 18. By the way, I was just tempted just now to change the sign. Okay. And we're going to multiply by 34 on both sides. Shall I do it in my head? Yes, I am going to trust myself. R is greater than, I'm talking about 270 plus 36, which is 306. What I did, just so you can see it, is I'm multiplying by 30 plus 4. So that's why I added the 270 plus the 36, and that gives me my 306. I'm multiplying by 8 on both sides, and I get Q is greater than or equal to 80. And I'm going to multiply by 3. You're probably going to be tempted to divide by 3. That is a really common, it's very tempting to do that. It's less than, and I'm multiplying by 3, which is 372, it looks like, huh? Make sure. 336 and 12 makes 372, yeah. I'm going to multiply by 2.5, and I'm going to do it on the side. 5.14 times 2.5. Oh, you know what? I'm going to use my trick. I'm going to use my multiplication trick. Let's see if I can do it. I am going to get 1, 2, 8, 50 with 3 decimal places. Let's see if I did it correctly. 12.85. And then I'll show you what I did. 5 times 4 is 0, carry the 2. That's 5, and 2 more makes 7, and 25. I have a 0, and a 2 times 4 is 8. 2 times 1 is 2. 2 times 5 is 10, and we get 0. 8 and 7 is 15, carry the 1. 7 and 5 makes, 7 and 1 makes 8, and a 2 and 1, and we have 3 decimal places, 1, 2, 3, 12.85. Now, what I did is, if I ever wanted to multiply 514 by 25, the trick I used was, I want you to imagine that you have 514 quarters in a giant jar at home, or you have a big jug of quarters, and you're going to divide them up. What would you do? Well, most people would start stacking them in stacks of 4, wouldn't they? So what I did in my head to do this problem is I did this. I said 4 goes into 514. And I did it in my head. It seems like it would be hard, but it's really not that hard. So I got my 1. That's where I got that 1 from. And then I subtracted it in my head, and I got 11. And then I said 4 goes into 11 2 times, doesn't it? And I have a 3 remaining. So that's where I got my 2. Now I had a 3 remaining, and I brought down the 4. And I said, 4 goes into 34 8 times with 2 left over. So 8, and then I have 2 left over, and 2 quarters is 50 cents. And of course, because of the decimal, I moved the decimal 3 places. Anyway, for those of you who want to learn how to multiply by 25, you divide by 4 in your head. Now, just to show you that it's a little bit easier, for example, 17 times 25, most people can divide 17 by 4 in their head, and 4 goes into 17 4 times, and you have 1 quarter left over. Try it a few times, teach it to somebody else, and you'll be able to do it too. So anyway, now let's make sure I get it right. 12.85 is what I get, and it has to be less than B. I actually put it in there now. And we're almost done. I'm going to multiply by -1, and I'm going to change the sign. So I'm going to get negative 16.42 is less than or equal to A. I had to change the sign because I multiplied both sides by a -1. And I left it where it was. I left it on the other side. And this one I'm going to divide by 1.08, and I'm going to get P is greater than or equal to -1. I just divided by positive 1.08 on both sides. This is taking forever. I'm so sorry, guys. Divide by 2.5, and you're going to get N is greater than or equal to 4. 2.5 goes into 10 4 times. And it looks like we have one last one. I'm going to multiply by 5 on both sides, and I'm going to get H is less than or equal to. If I multiply by 5, I am going to get 13.5. So it's negative 13.5. And just to be sure, I don't want to make a mistake. I have a 5 and a 3 and a 10 and a 13 and a decimal right there. So it looks like H is less than or equal to, I'm not changing the sign, negative 13.5. I hope you guys stuck with me, and maybe you learned how to multiply by 25 in your head. And I hope I convinced you that even people who do math for a living can still make arithmetic errors, especially if they never practice. So practice your arithmetic. And it looks like we're done. And I hope you guys finish yours as well. Have a nice day. Bye-bye.